Good morning. This is the first video in Unit 3, and Unit 3 is the unit in which we are going to talk about energy and enzymes, about cellular respiration, and about photosynthesis. Why are we starting by energy and enzymes? Because Unit 3 involves the discussion of energy absorption, energy transfer, energy storage, as we would be seeing through the processes of cellular respiration and photosynthesis. And so we have to master the concept of energy first. And then cellular respiration and photosynthesis are also full of biochemical reactions that necessitate the catalysis or the speeding up by enzymes. As you know, enzymes are 3D proteins, and those 3D protein molecules have a particular configuration, and they have this particular shape that we call the active site, which is a specific domain on the molecule. And that specific domain on the molecule can bind with a specific reagent that we call the substrate. So in order for the 3D, or in order for the enzyme molecule to be functional, it has to be in the 3D configuration. And it is worth saying that all enzymes are proteins, but not all proteins are enzymes. We will be discussing all the concepts related to the enzymes over the coming slides. But let's first talk about energy. What is energy in general? Energy is the ability to do work. Whenever a particle or a human being are capable of doing a certain work, then this particle or that living organism have energy. We have several types of energy, and we will start by potential energy. As you can see, for example, in the picture to the left, the car that is on the top of the hill has potential energy. Why? Because as the car was going upward or up the hill, the car had kinetic energy, which is the energy of motion. And then after having stopped for a while at the top of the hill, it has a new type of energy, which is the potential energy. And the potential energy is the energy that is stored in the car because of its position. If the car is at the bottom of the hill here, it would have zero potential energy. The potential energy would be zero. But whenever you have an object that is above the level of the ground, then it will store inside it a potential energy. How much is that potential energy? The formula for the potential energy is mass multiplied by gravity multiplied by the height above the level of the ground. M is the mass of the car. Gravity, G, is the acceleration due to gravity, which is constant, of course. And H is the height above the soil. For a particular car, for the car we are seeing here on the slide, we have a constant mass. Since M is constant and G is constant, then the potential energy will be directly proportional to the height. So as the height increases above the ground, the potential energy of the car increases. On the other hand, if you have two cars that are at the same height, in such a case, the height will be constant, the acceleration due to gravity will also be constant, and potential energy will be directly proportional to the mass, meaning that the heavier the car or the greater the mass of the car, the greater the potential energy. And this is what you can see here in this example of the ball. When the falling ball or the falling particle was above the level of the ground, it had a potential energy that was equal to the mass of the particle multiplied by the acceleration due to gravity multiplied by height. And when this particle was left to fall down, it fell down with a velocity v1. But when it reached the ground and stopped, the potential energy is now zero. Why is the potential energy zero? This is not because the particle has stopped, but because when it is just above the level of the ground, the height above the ground is zero. At the beginning of the fall, the kinetic energy would be equal to the mass multiplied by the squared value of the initial velocity, which is v1, divided by 2. And then when the particle dropped down, the kinetic energy still has the same formula, m multiplied by v, by the square of v divided by 2. But in such a case, the velocity would be the final velocity and not the initial velocity. What's the relation between the potential energy and the kinetic energy? As you see, the potential energy, and as it is written on the slide, the potential energy is the energy due to the object's position, but the kinetic energy is the energy due to motion. At any time, mechanical energy is equal to potential energy plus kinetic energy. This means what? This means that as the potential energy of the body increases, the kinetic energy decreases for a particular mechanical energy of that body. So if we have two bodies that have the same mechanical energy, but one of them has a higher potential energy than the other, so the one that has the higher potential energy will have a lower kinetic energy. Now, the potential energy also depends on the structure of the molecule, like, for example, the complexity of the chemical molecule. Now, if we have free atoms that are not in their full octet state, so they are unstable, and they are all the time moving, they have a certain kinetic energy. For example, oxygen atoms. Oxygen atoms have an outer shell that has 6 electrons, so it needs to react, or every oxygen atom needs, for example, to react with another oxygen atom through a covalent bond in order to share electrons. And when they share electrons, they can reach the full octet state. So the oxygen atom, before reaching the full octet state, will be in a state of continuous motion,